Let's try to create these two gears in Autodesk Inventor using the power transmission tool. Now, we're not going to design the frame or the C-ring because you can download these from Engineezy.com. I'm just going to try to see if I can find the specification on these gears so that we can practice making gears as a classroom exercise. Now, if you want the gears plus the frame and the C-ring, you can download it from this site. Of course, I'll put this in the description of this video. So to get started on making these gears, you kind of have to measure a few of the parameters of the gear. Let's see if I have them handy. Yep. Okay. So I already typed them up. We're going to check to see if all this works. The first thing you want to do, as it says there, is go up here and make a new assembly, because in that area, you're going to get a feature or a tool called Power Transmission and Spur Gear on the Design tab. So you're not going to see that if you create just a normal part. It's going to ask us to save this right away, and I'm going to save this as Helical Gear. It's going to overwrite the one that I had right there. And it looks like I have that other file still open, so I'll just put underscore version 2. All right, so the other thing that you'll have to notice about this is that you go over here and you compare this diagram or this window to this other one over here, and you see a couple of differences. One of them is it's got more visibility here. But the other one is that when you set this to distance, let's see, what does it say? Center distance right there, as we see in the diagram, you do not see a module here. And that's because this document or this assembly is not set up for metric. So if you cannot find module right there, that just means we need to go over here to Tools, Document Settings, Units, and go down here and go under millimeters. Now watch what happens when we go under here under Design, Power Transmission, and Gear Assembly, or I'm sorry, Spur Gear. You're going to see now that it's going to show module, and I guess I really should have put in my instructions that it's 0.7 millimeters. I'll go back and do that in a minute. All right, let's make sure we got these other things here. Some of these are going to be grayed out because they're going to be controlled by what you put in for the number of teeth. And if you count around the outside perimeter of this gear, this one up actually here was made in SolidWorks, but now I'm working in Autodesk Inventor, and we're going to find out that this is going to be a left-handed gear as opposed to what Engineezy made, which was a right-handed gear. And we'll make sure that these work, of course, before we um, post this video. All right, so I guess I'll go in here and modify this document because we did notice it needs to be in millimeters. So we'll save that for future reference. And the L stands for unitless, so there's nothing there. Let's go down the list, and then we need to have this helix angle not so that it's straight up and down, which is 0, but instead 45, like this. And the pressure angle needs to be 20, and the face width needs to be 20 as well. Now, I guess we can make this gear over here match exactly, but the thing is, all we really want is one gear, and then we'll just print it twice. If we do it this way, it's going to print two gears side by side, and we really want to keep them separated. So for gear 2, let's just say no model so that it doesn't create it. If you forget to do that, you can come down later and disable and hide the gear number 2 if you want to. Now, let's see. Did we get everything right? It looks like it's okay. So then it says, all right, here's what I'm going to make for you. And it says there's some kind of calculation error. I forget what this has to do with. It might be because we're matching a left-handed and gears together that are parallel rather than rotated 90 degrees. I think that's what that's errors for. But if you go past that, you're going to see that you're going to get the gear. And if we click right there, maybe orbit around a little bit, you'll see that this looks very much like what we have over here. And we can count the number of teeth and see that it's 25. Now we're going to need a hole through the middle and a chamfer as well to make it so that the axis can go through here. There'll be, a rod on Engineezy's site right here. So there's a built-in axis here, and then there's a removable axis right here. So let's go ahead and see if we can get those created as well. All right, so going down the list here, we need to have a hole that's 7.4 millimeters in diameter. I think in class I accidentally said 8 millimeters. So we're going to make it a slightly smaller through hole to make sure that we have a tighter fit on that axis. Now to find the center of this, well, what we can do is, I guess, first of all, just put a circle that represents the through hole, first of all. And here I'm going to say 7.4 for the hole diameter. But then what I can do is say, I want to add some constraints. I want this to be concentric with the gear itself. So it looks pretty good. And then we're going to go down here to 3D model, and we will cut that all the way through. And so we're going to say through all like that. Now what we want to do next is put a little chamfer on there to make it so that it's easier for those axes to go inside. So we add chamfer, and we're going to make this a small one, as it says down here, 0.5 millimeters. And we want to select the edges on this side, and then shift and then middle mouse wheel to rotate around, orbit around to put it on this side as well. We can personalize this gear as well. What I'd like to learn how to do is actually how to um, make a raised area, but for some reason, when we're in this assembly view, we can only make parts that are engraved. I'll show you what I mean. Let's go back and draw a circle on this plate right here. And I think we said in class when we did this, we want to sketch on this plane. Let's see if we can sketch on this plane. Oh, wait, we got to go to sketch. And then we put a circle, and we want to draw on this surface. And, I guess we can just kind of do it halfway like that. And then for this one, I think we said 11 millimeters. And then we're going to center this one up with the outside. And this is what we're going to draw on. And we can go ahead. Well, I'm sorry. This is what we're going to put our letters around. So we want the letters to wrap around in a circle. So if we go back over here to this one and make it a construction line, we can then go over to text and look at this right here. Geometry text. And so I don't think this will actually do anything until you have a circle like that. Let's just put our SFA logo on there, and let's see what kind of font. Well, not logo, but the letters rather. And you can put your 3 initials on there. So I'll do that with my initials. And circular pattern. I guess it's not really circular pattern, but circular, I guess, base for the lettering. We're going to use a font that is, remember to highlight all, Control A, and it needs to be 0.15, and we'll make it bold, and that's about all we need. Let's see how that looks. Looks pretty good. We can click it and put a little bit more space in between them so they wrap around like that. And what I've been trying to do is to figure out how to, you know, extrude this. But it looks like it only allows you to cut when you're in assembly mode. So if somebody knows how to fix this, if you can put this recommendation in the chat, that would be great. But what we're going to do instead is we're just going to go over here to engrave, if we can find it right here. Usually it's up here. I guess we'll just have to do a cut. And we're going to make it just 1 millimeter. And that's what we're going to go in that direction. So it's still going to be visible after we print this, but it will not be outstanding. It won't be standing up or offset from the surface other than, a cut. And so that's going to be all right, because if we look back over here, if we try to raise this up, it might run into something. Well, especially if you did it over here. But if you raise the letters here, that would be fine. But over here, it would not be. Okay, so let's see, where are we at? There and there. Did we do everything? Yeah, and we're going to go over to the printers and the library to print those. But this is basically setting up of the helical gear. Now, to save it to a file so that you can 3D print it, of course, you want to go to some kind of export. You could save it as an assembly file right here, like so. But in order to print it, you have to go File, hover over the print. So don't click Print here because it'll print it as a PDF file. Instead, you want to hover over Print and select Send to 3D Printing Service. And it'll go, oh, you want to save this as an STL file. And so at that point, we can save that as a .stl file. All right, let's remember where this is. I think this is under Documents. Yeah. save. And then so when we go over here to some kind of 3D printing software, such as Bambu Studio, we can just hit the plus sign like this, and then go over to documents where it was, and then Autodesk Inventor, and then Baja and Helical gear. Now, if it's not setting up and down like that, you certainly want to rotate that over, but it looks like I got lucky. Sometimes what you'll do is you'll find that these are like they're found like this on the surface, or more likely, flat. But what you do is you use some kind of automatic adjustment like this. There should be no supports when you'll see that there's no brim or anything like that, because it's just drawing it straight up and down, or it's extruding it straight up and down. Now what you can see here is the layers of this as it begins to build up. It goes all the way through the part. I like how it spirals like that. I didn't think about that. And then we can kind of see that going from the side like so. And so it's got about a 20% infill, I think, is what we put it on. You see a lot of open space in this area. And of course, a flat bottom and a flat top with the letters on the top. Let me see if I can install also Prusa slicer, and see if I can show you the same process with another type of slicer. So I'll be back in one moment. Let me pause the video. Okay, and I found the software, downloaded it. It doesn't look like it installs it per se, except for just creating a directory with an executable in there. Before I go and do that, I do want to mention that we could go over here and, of course, download this. I think I've already done that. So I want to show you what you would also do if you wanted to to put the frame in there with your custom gear, even though this is meant to be kind of an identical design. So what you want to do is go over here to the prepare and then start adding in the other files that you need. I think I downloaded them and put them in, let's see, this directory here. We don't need that gear. We don't need that. We just need these files that came from Engineezy. You want to say no to that, and then what you can do is auto arrange. You're going to need two of these gears, so you can hit Control C, Control V to copy and paste those, then arrange them again. This right here is not the best orientation to print. Obviously, you want to lay that flat, so we're going to say lay that flat there. And this one you probably want to put up on its end as well. Now, there should be two of these C clips, so we're going to put those over there. Arrange it one more time, and maybe put it over here. I think there's probably going to be an adhesion around this. Let's see if it's going to create some brim around them to make sure it stands up nice and straight during the entire print process. And there it is. So once you print this, you can assemble it. This brim is going to tear off. This one's going to go over this type thing right here. You put a C clip right there. Then this one's going to go through both holes, through one of the gears, and then have a C clip on the other side. Now let's see if we can do the same thing with Prusa slicer. It's the first time I've ever been exposed to this, but look how similar it is. It looks almost the same kind of thing here, including, where did Clippy come from? I was kind of surprised to see that. It looks like it's got the same kind of pattern here. Or we can go in there and go over to downloads, and let's see if we can figure out where we put those files again. We want to get everything except for the right-handed gear there. We don't really need that. And this is actually another thing that we're going to print alongside it. So I forgot to include that a minute ago. But this is an example engine for printing purposes. Let's see if it's going to say do the arrange for us. I don't see it here. This is often the symbol for arrange, and it did a pretty good job there. All right. Looks like it wants to make it green. We do want to add in the other gears though, and let's see, where did I save those at? I think I put them in documents, and then inventor, and then I put it in the Baja folder. And this should have our initials on it. And let's make a copy of that. I think Control C and Control V. Look at that. It's all universal. And we can arrange this again. And of course, one of the things we see is we don't want this to be printing like that. We want it to rotate. And I'm not really sure how to do that, but look at this over here. That says rotate. This says face on face. So that means select the face to go down. So it's a little bit different. You have to do 2 clicks there. So this one, we don't want to print it sideways. We want to place it on this face. Slightly different. How about that? How easy is it to go from um, Bambu Studio over here to Prusa Slicer? And again, this is my first time using this application. All I'm doing now is looking for the slice button. And maybe I should pause the video to find that because everything else seems to be really intuitive. I'll be right back 1 moment. That was pretty easy to find. I just clicked down here, guessing what it was. And that's going from the solid body over into layers. And it looks like, it's very similar to Bambu Studio, where you're seeing all of the layers from top to bottom. This time we have the engine in place. I wanted to mention, though, that we do need to put supports on this one. I don't see supports, but this one needs it, like right in this area. These other ones do not need supports. Oh, here it is, supports. So let's say supports on build plate only, and then let's reslice it to see if it puts those in place for us. So let's go back over here, preview. Has it already put the supports in place? I don't see that it has. Let's go back to this view and then this view. Okay, it put some kind of brim around here. That's interesting. Oh, it put way too many supports in there. So we don't need all of that. Yeah, that's way too much supports. Let me see if I can find some better settings, especially as we take this over to the makerspace in the library. So we don't want all of that. I'll find the proper settings and share that with you in a moment. All right, so by comparison, if we go over here to Bambu Studio and load up that file, that was the radial engine, and also auto arrange that so that they don't print on top of each other. This one really needs to stand out by itself. I don't think that it's going to put supports in there by itself. Let's see if it's got supports enabled. Um, yeah, it doesn't have supports enabled. So that means when we slice this, I'd like one thing we need, and that's right down underneath this gear, try to print in there. Now, this is supposed to be a print in place part. Looks like it did pretty well. You see there's no brims or anything like that. If we go up underneath there, yeah, it still needs to have a support right in that area. So let's click on supports, and it says threshold angle is 25. Maybe that's the critical area or the critical value to use. And looks like it did way too much. So we don't want any of this stuff in here. Okay, let me see if I can get closer to figuring out what the actual values are. So pause again. So one way to find the settings is to do a little research and go to where we downloaded this example part of file for, or from rather. So radial engine. And we found this on makerworld.com. All right, let's see if this loads up pretty quick, hopefully. Looks like it's pretty slow loading at this moment. So I did click on 3D models first and then typed in radial engine. I'll let that load and pause the video. Okay, so there's various radial engines, but this is the one we're printing. And you'll be able to see on their instructions for their site is that there should be a support right underneath this middle part that's right there. So let's download this file directly from their site to figure out what the settings are for the support so that we only get one and we're not just overwhelmed with a lot of material we have to peel off. Because I was able to print this with just this one thing here and it worked beautifully. All right, here we go, loading up into Bambu Studio. And we're going to maximize this window. There's the part. Now, if we slice it right away, I bet we're going to see it has the proper supports. And then we'll go check out what the actual settings are. And look at that. There it is, right there. So that's the thing that we wanted to see. And you can see it's holding up that one piece right there. Okay, so that's the only thing we want. So we look at supports, and it says the threshold angle is 1 degree. So if we go back over to our previous one over here, and maybe change that support to just 1 degree, I wonder if we would achieve the same thing. So let's go like that, and let's reslice it. We'll have no supports around anywhere around here. We can maybe get a brim around there. That's good. But you know what? It really should not have all of this in there. So something still did not happen properly. Let me see if I can pause the video and find out. So I did want to show you some of this research that we're doing. So enable support, normal default one, check, check. And so there was another checkbox here. We only want things that are on the build plate. And that normally means is that we have um, a way to get from the bottom to the top. Still, it did not do it properly. Let's see, check, normal, default, one, da da da. And we have the same thing there. Okay, I do see a difference in the settings right here. So let's change this to 0.2 over here, a little bit lower resolution, like that. And then we'll just say use all these modified values that we just made, slice it one more time. See if that's the reason why we got swords in there. It might be that there's might be some rafts that are coming in, but uh-oh, looks like we figured it out. I guess I shouldn't say uh-oh, because that's actually the proper thing. So the issue here was, in order to get that one support, is it had to be at a certain resolution. If you wanted a higher resolution, you would need more supports in there for smoother surfaces up here at the top. But we're happy with this right here. So this is what you want to do if you print it out on a Bambu machine. But again, we're over here. We don't need any of this kind of stuff. So let's kind of go over to the supports. We did do it properly on the build plate only, but let's see if there's some kind of threshold angle that we can set over in Prusa Slicer as well. Okay, so I found the correct settings. You want to go under expert mode so you can set these parameters. And it's going to be under, I think, printer settings, support material. You want to check those two checkboxes, and then it was on 0. I set it to 1, just like what we saw over in Bambu Studio. And let's see what else I changed. I think the layers, yeah, I changed that to 0.2 so that it would match up with Bambu Studio as well. Go back over to the platter and say slice now. It's going to slice up the layers again. Let's just make sure that it gave us a good, yeah, there it is. The nice support right there. It's the only thing that we needed. And you see that it's really supporting this object right there. So it's this thing, this crank that goes around and around. It needs to be supported from underneath. So all that careful stuff, just so that you don't do a lot of you don't have to do a lot of peeling away of the support material around here. Um, we might be able to get by with this not falling over. In other words, we could probably exclude a brim here. I'll just see if I can put a brim on one of them and see if that works. So one moment. Yeah, I guess I forgot to mention that I did go over here before slicing and I said no brim. I think if we do outer brim only, it's going to do that for every part in the list. I don't think we necessarily want that. Oh, actually, it did not. It did not make any brims, even though I went over here and I said brim and skirt, outer brim only. Brim width, and I guess I said 0 here. So I think if we did more, then that would be, it would probably put them on everything. If we said like, 5 and then went back over here as a slice, it'll probably put a brim on everything, which would be kind of a lot of work to, remove all of this brim material. So we don't want that either. I was just hoping to get it on one because the tall item right there is sometimes problematic about falling over. But as long as you put enough glue on the surface, let's just try it that way. So under expert mode, I don't think you can go in here and say, get the axes and then just kind of customize it. Let's see if there's a way to lift up here. Yeah, I don't think these have any settings about whether they're brims or not. Wonder what that means. So what if we go like this and select this one and then say I want a brim on this one? If you go here, yeah, it looks like it keeps it on every part. All right. So folks, what we're going to do is leave it just like this and doing one last slice with Prussia, excuse me, Prusa slicer. And this is the only support that we need. Okay, and just make sure that you and the staff member put enough glue there so this one doesn't topple over. These other ones are not going to have any issues with that, but sometimes this one can topple over. And if there's an issue with that, we can just print only these axes on a different printer and get those parts to you as backups. I hope you enjoyed this experience. You should have a moving engine when you get through this, as well as moving gears that are at 90 degrees with respect to each other on their rotation axis. All right, have fun, and I'll see you soon.